Welcome to Topic Wise. Today's topic is magnification M. The ratio of height of the image to the height of the object is known as the linear magnification. M is equals to height of the image by height of the object. It is also related to the image distance V and object distance U, as M is equals to minus V by U. In simple language, this magnification is a number that tells how many times bigger or smaller the image is compared to the object size. Suppose image size is less than that of the object size, then magnification is less than 1, and image size is equals to the object size, then magnification is equals to 1. If image size is larger than the object size, then magnification is greater than 1. Here let me see some situations. Here this is one convex mirror and one object is kept in front of the mirror, and this is image formed by the convex mirror. And if the object height is of 2 centimeters, then convex mirror can form, suppose it can form 1 centimeter image. Then M is equals to height of image by height of object, that is equals to height of image is 1 centimeter and height of object is 2 centimeters, which is equals to 0.5, which is less than 1. So, here our magnification is, numerical value of magnification is less than 1, and this plus sign shows that image is one erect image. And when you come to the plane mirror, this is one plane mirror. Plane mirror can form one image which is equal to the height of the object, and here image size is equals to object size. Suppose each one is of 1 centimeter. So, we will get 1, means image size is equals to the object size, that is nothing but magnification is equals to 1, and plus sign shows that this image is one erected image, and this is M is greater than 1 plus 1. What is its meaning? M is greater than plus 1 means number shows that image size is more than that of the object size, and here plus sign shows that image is one erect image. Suppose when object is between pole and focus of a concave mirror, it forms one virtual erect and enlarged image. Here suppose height of the object is 1 centimeter and it forms an image which is of 2 centimeters. Then magnification M is equals to 2 by 1, which is 2. The number is now greater than 1. So, magnification is greater than 1, and this plus sign shows that this is one erect image. And here when object is away from center of concave mirror, center of curvature of concave mirror, then it forms one diminished small size image, and which is one inverted image. Here number is less than, magnification is less than 1, that means size of image is less than that of the object size, it is one smaller image, and minus sign shows that this is one inverted image. When object is kept on center of curvature of a concave mirror, it forms one image which is equals to the object size. So, that M is equals to 1, that means height of image is equals to height of object, and this negative sign shows that the image is inverted image. And when object is between center of curvature and focus of a concave mirror, then it can form one image. And how it has magnified? M is greater than 1, that means size of image is more than that of object size, that is it is one enlarged image. M is greater than 1 means image size is greater than that of the object size, and here minus shows that this is one inverted image. By using this magnification formula, let we solve one numerical here. Find the position, size and nature of the image formed by a spherical mirror from the following data. Here given data is u is equals to minus 20 centimeters, f is equals to minus 15 centimeters, HO height of the object is 1 centimeter, that is plus. And let us start the problem. Let us solve this. U is minus 20 centimeters, object distance is equals to, and focal length is equals to minus 15 centimeters. Focal length is minus 15, that means it is a concave mirror, and height of the object is plus 1 centimeter, that means object is kept above the principal axis. And what we had to find out? Position of the image, that is V is equals to how much, and size of the image, height of the image is equals to how much. And we also discuss about the nature of the image formed. And to find the V, we use the mirror formula, that is 1 by f is equals to 1 by v plus 1 by u. We do not know v, so 1 by v is equals to 1 by f minus 1 by u, and substitute the values. 1 by v is equals to 1 by f is 1 by minus 15 minus 1 by u is equals to 1 by minus 20, and this is equals to minus 1 by 15 plus 1 by 20. Here 60 is LCM, minus 4 plus 3. So, this is minus 1 by 60, that is 1 by v is equals to. From this v is equals to minus 60 centimeters. And now we have to find out the size. Size we can find by using the formula m is equals to, magnification is equals to height of image by height of object. Here in this, if we use this equation, then we do not know the two quantities, that is magnification and height of image. So, better we use another formula, that is magnification is equals to minus image distance by object distance. So, now m is equals to minus image distance is equals to minus 60 by object distance is equals to minus 20. So, this is equals to minus 3, m is equals to, and substitute that value in this equation. Minus 3 is equals to hi by HO is equals to 1 centimeter. From that hi is equals to minus 3 centimeters. Now, let we discuss the nature of the image. First we see here we got the V value as negative minus 60 centimeters. That means image has formed at the same side of the object, 60 centimeters from the pole of the mirror, and magnification is equals to minus 3. This 3 numerical value tells us that this is greater than 1, that means image is enlarged image. This is 3 times enlarged. And a negative sign shows that this is one inverted image. And when you come to the height of image, this image is one enlarged image and it is of inverted image. Now here object distance is away from the focus, that is between center and focus, center of curvature and focus. We know that when one object is kept between focus and center of curvature, we get one inverted, enlarged and magnified image in concave mirror. Thanks for watching.